So I want to take a minute to talk about a concept that is controversial, and this is what's called a p-value. So you kind of know your p-value from your t-inverse function. So p-value is basically your confidence. Now, when we start doing t measurements, or t calculations, we're setting a threshold. And usually what we say the threshold is that p is less than or equal to 0.05, so there is a 5% chance or less that the variance that we're observing is due to just random fluctuations. So basically what we're saying with p-value 0.05, there's a 5% chance that the variance can explain the differences in the two averages we're looking at. Now, this is actually not a good way to go about doing this. It's fine to set a critical p-value. Like, that is something you should be doing. But setting it and forgetting it is a problem. So let's say we have two data sets, x1 and x bar, and y1 and y bar. And we do a calculation. And both pass at the 95% confidence interval. So p here is definitely less than or equal to 0.05. But let's say p here is 0.001 versus p here is 0.000000001. Which answer is far more confident? Well, this is. Oh, sorry. This one is. We are very confident that these differences are different. This kind of squeaked in. It's a 1% chance that these differences can be explained by variance versus the 5%. So both of these would be considered statistically relevant differences, but if I just say, well, these both pass at the 95% confidence interval, they're implying that these are both the same levels of confidence, and they're not. So it's kind of a mixed feeling in higher education about reporting p-values. You should, and there is a formula to figure this. Is the t-distribution function within Excel. But in terms of teaching undergrads, it's kind of a weird thing is that we tell you to set your t-value to 0.005, and this does give you your 95% confidence interval. 95% confidence intervals are good for quick and dirty tests to see if your values are statistically different. But the thing is that it's only telling you if you meet the minimum requirements. It doesn't tell you how well you met those minimum requirements. So why is this kind of controversial? Well, the p-value here is going to depend highly on your number of n's. So much as your t-distribution, t-value depends on degrees of freedom, the more n's you get, the better your p-value becomes for a given difference. And if you go look it up, there's actually something called gaming your p-values. And what people can do is you can artificially make your p-value look better than it is by creating replicate measurements and things like that. Why is that not really accurate? Well, measuring the same terrible measuring the same terrible unknown over and over and over again doesn't mean that you got better data. But because n keeps getting bigger and bigger and bigger, your variance may stay constant. Your measure may be equally bad, but because you've taken so many bad measurements over and over again, the p-value begins to look bigger and bigger. So p-value, much like standard deviations, like a lot of statistical measurements, is going to depend on you being honest to yourself and understanding the concept of what you're doing. So personally, I prefer to report p-values and then say that instead of doing the student t, going through and calculating the p-value for a given t-value. So you can do this in Excel where you do a t-calculate and then you backtrack out what the p-value is. But some people prefer just to say, well, just look at t-critical, because if it's less than t-critical, then you've met the threshold. Like, it's not like you were going to subjectively reject it. Your reason for accepting or rejecting a hypothesis is always going to be 0.05. It doesn't matter if it's this or this, you're going to get the same outcome. Just for me, I think it's better to report the p-values to kind of give a feel, particularly when you have two different numbers, how confidently you know those two numbers. So again, it's a fun little controversy. I highly encourage you to try and read the Wikipedia article on it. It is quite fascinating. Albeit very hard to understand, but yes, p-values are a little controversial.